Hey everyone, Radzion here. Today we are going to build a typed routing navigation system for React apps from scratch without using external libraries. While most web applications benefit from full browser navigation with URL path names, there are specific scenarios where simpler routing solutions make sense. Desktop apps built with Electron, Chrome extensions, or simple browser widgets often don't require traditional URL-based navigation. These applications typically bundle everything together without lazy loading, functioning more like traditional software. There are also cases where your specific requirements aren't easily addressed by existing routing libraries. Today I'll share a routing foundation I developed for such a situation, which now use whenever traditional browser navigation is needed. So for most standard web applications, I recommend using Stack router as it provides excellent typed navigation out of the box. If you're curious about implementing a custom router for your specific needs, let's explore how it works. You can find all the source code in the GitHub repository, linked in the description below. To illustrate the implementation, let's create a simple widget with three distinct views: a home screen with calculation state, a settings page, and results view. We'll define our app view type with three variants: home, settings, and result. The home and result views will also include a calculation state. The home screen allows you to select a calculation operation and generate two random numbers to work with. When you navigate to the results view, the application displays the calculated outcome based on your selected operation and inputs. We'll define our calculation operations as a sum, subtract, multiply, and divide, and create a calculation state type that includes inputs and the selected operation. When you launch the widget, your initial view displays the home screen with a predefined calculation state. In our router implementation, a view consists of both a path identifier and optional state data. This approach mirrors how traditional routing systems work, where data is typically passed between views using URL query parameters or browser history state. However, since we are building a solution independent of browser navigation features, we are implementing our own state management system. To define views with type safety, we'll create a generic views type that receives a type parameter t. In our application, this parameter will be the app view ID type, a union of home, settings, and result streams, ensuring our router recognizes only valid view identifiers. With our views type defined, we'll now map each route identifier to its corresponding React component, establishing the connection between our navigation system and the actual UI elements rendered for each view. To enable backward navigation within our application, we'll structure our navigation state around two key elements: an array that maintains the complete history of visited views and a numeric index that tracks our current position within that history stack. This approach mimics how browser history works while giving us full control over the navigation experience. The getStateProvider setup function is a utility from Radzion Kit that generates a React context provider and a custom hook for state management. In our navigation system, it creates a provider component and a hook to access navigation state throughout the application without writing boilerplate context code. To implement our navigation system, we'll wrap the application in a navigation provider component that exported the navigation state to all child components throughout the component tree. We initialize the navigation with current index set to 0 and a history array containing only our previously defined initial view. Next, we'll implement a layout component to create a consistent container for all views in our application. This layout includes a back button in the top left corner that remains disabled unless there is both a previous view in the navigation history and the current view isn't the first one in the sequence. Now let's implement the hook that powers our back button functionality. The useNavigateBack hook provides a clean abstraction for navigating to previous views in our history stack. It checks if backward navigation is possible by verifying the current position in our history array and simply decrement the index when called. The useUpNavigate hook provides type safety for navigation, ensuring you can only pass views that conform to the app view type definition. This prevents potential runtime errors by catching invalid navigation attempts during development. The getGeneric useNavigate hook powers our navigation system and provides the foundation for type-safe navigation. It manages history by tracking view entries and their associated state, handling both regular navigation and view replacement throughout a simple options parameter. When called with a view entry, it either adds a new history item or updates the current one, maintaining the appropriate index position for backward navigation. With our navigation hooks in place, we now need a component that renders the appropriate UI based on the current navigation state. The active view component serves as a bridge between our navigation system and the actual view components. It extracts the current view ID from our navigation history at the current index position, looks up the corresponding component from our views mapping, and renders it to the screen. To demonstrate how view state changes work, a home view component provides two interactive elements: a Radzion input for selecting calculation operations and a button to generate new random inputs. When users interact with these controls, the application updates the state by pushing new view entries to the navigation history array, ensuring both the UI and internal state remain synchronized. To properly handle state in our type navigation system, we need a mechanism that preserves type information across different views. When accessing a view state, we want TypeScript to know exactly which properties are available based on the view ID. The useUpViewState hook provides this capability by leveraging TypeScript's type system to extract the correct state type for each view. This ensures you can only access state properties that actually exist for the current view. The useUpViewState hook builds on a more fundamental hook that manages state updates for any view type. The useViewState hook handles the core functionality for accessing and updating state within our navigation system. It returns both the current view state and a setter function that maintains our navigation history, similar to React's useState pattern. When state changes occur, rather than simply updating the existing entry, it creates a new history item with the updated state, allowing users to navigate back to previous states while preserving the view's identity. Clicking the Calculate button on the home screen triggers a sequence of navigation actions. A new view entry is pushed to the history array, the current index increments, and the active view component responds by rendering results view. The result view then accesses the calculation state through the useUpViewState hook to display the computation outcome. This lightweight routing solution we've built today provides type-safe navigation for React applications that don't require browser-based routing. If you found this video helpful, please hit that like button and subscribe to the channel for more React development tips and techniques. Drop a comment below if you have any questions or if you'd like to see more content like this. Thanks for watching, and I'll see you in the next one.